Last video, I showed how to use the orders of operations when it comes to rational equations. Now, let's use those to solve for x. Cool. Now, subtraction, and to be honest, even if it's multiplication, the best idea here is just to get that common denominator. So, let's look at our biggest term. We don't really want to think about simplifying because then we don't know what this will get. We don't know what you have to divide by that. So let's just look at how can we multiply these two to get to this. So 3 times 2 is 6. So let's multiply top and bottom is 2. Now what do we have to multiply x by to get 6x squared? 6x. Now, our common denominators are now all the same. Six x squared is minus 6x over 6x squared. All right, now we can just combine this right here. We can just make this into just one whole fraction. We just get 2 minus 6x. Now we can do that because we now have common denominators. Now, because our denominators here are identical, we know that we can just forget about them. Because no matter what, at some point, we would just have to, get rid of this. What we could do is we multiply by 6x squared, that cancels, and then this would cancel. We would have to multiply this over here, which would cancel that. So that's why when we're working with rationals and we get that common denominator, we can just forget about it. We can ignore it. So this then just becomes 1 is equal to 2 minus 6x. So minus 2, this just becomes minus 1 is equal to minus 6. Divide by minus 6. X is equal to 1 over 6. Nice. All right, here we have a new rational equation. These aren't very apparent. So let's solve for x. Now we can clearly see what our denominator should be. So we need to think, what can we multiply this rational equation right here by to make our denominator look like this? Well, the first step when you have a denominator that isn't just in its simplest form, we just factor it out. We just take an x out of this. We get x times x minus 5. Now we know we have the x, but we don't have the x minus 5. So we multiply the top and the bottom by x minus 5. And now our denominators will be the exact same. So we're going to do the same exact step we did last time. We're going to forget about them. Because, like I said before, what we would do, they would be alike. We multiply it over here to cancel that. And then it would also cancel that. And it's just two things that are being divided by the same thing. So if you forgot about it, it's fine. So let's just write our numerators here. So we're going to have x minus 5 plus 3x plus 12 is equal to 7x minus 56. Combine our like terms here. 3x plus x is going to be 4x. 12 minus 5 is going to be 7. We're going to keep that the same. And now we can do like terms again. So we're going to minus 7. I know that this is 7 times 8. Adding another one, 7 times 9, that's going to be negative 63. Now, take 7x out, minus 7x. We're going to get minus 3x. divide once more. We want to get that x on its own. Divide by minus 3. Now our solution is going to be x is equal to 21. Pretty neat, ain't it? Okay, so I don't like how the lights are covering up part of this. So just to clarify, this is 1 plus x squared minus 5x minus 24 over 3x is equal to x minus 6 over 3x. So our common denominator is going to be 3x. So this just 1, which is really just 1 over 1. Multiply top and bottom by 3x. Now, our denominators are all the same. So let's forget about them like we did before. So here we have, wait a minute. Yeah, I thought I was doing it wrong. Hold on. Yeah. But we're gonna have 3x plus x squared minus 5x minus 24 is equal to x plus 6. So let's simplify. We're gonna have that x squared, 3 minus 5 minus 2 minus 24. Remember, we're also gonna have these. We're gonna get these over here, minus x, minus 6, because as we can see, we're gonna get a quadratic term, quadratic polynomial, which we can factor. So, minus x, minus 6. Just want to make sure I'm doing this right. Minus x. So, x squared, 2x minus x, that's going to be minus 3x. Minus 24 minus 6 is going to be minus 30. Oh, I saw my mistake. I was doing it wrong. X minus 6, x minus 6. So it's plus 6. That's why. So 24 plus 6 is going to be minus 18. Pretty cool. All that equal to 0. So now, zero product property, we know that we can factor this and then find our x's. So 18 and negative 3, negative 18, negative 3. This 9 times 2? No. 6 times 3? Yeah, I think so. In what way can we change 6 and 3 so that it would be equal to minus 3? Well, we could do 3 minus 6. So we don't have to do it the long way since there's no leading coefficient. So we can just say that this is going to be x plus 3 times x minus 6 is equal to 0. So we know through the zeros that this is going to be equal to, or x is going to be equal to negative 3 and positive 6. All right, I moved our function over so that we can look at it more nicely without the lights in the way, although it's still ruining me. So now, what's the first step here? Obviously, common denominators. Let's think here. Nothing here looks like it's already the biggest term. So we can recognize that at the end of the day, we're going to have to multiply this by x plus 2 and this by x plus 3. So we can know that our denominator in the end is going to be x plus 2 over x plus 3. So let's do some multiplying. We know this and that, x plus 2, x plus 2. This is going to be x plus 2 on the top and x plus 2 on the bottom. And also x plus 3. Because it's just the one, it needs both. That's why. Then multiply top and bottom by x plus 3. Just double checking because I don't want to make another mistake like I did last time. So we know that in the end we're going to forget about our denominator. So let's not write the whole denominator out. let's just look at the top and bottom. So we're gonna have x squared, no. Right, let's write the whole thing out first before we simplify. X plus 2 times x minus 2 minus this right here, which is going to be x plus 3 times x plus 2. But I'm going to nest that in another set of parentheses because we're multiplying this by that entire, no, not multiplying, we're subtracting by that entire fraction. So that's why I'm nesting it inside this bigger set of parentheses to show that we're subtracting by the whole thing, not just that first term. Cool. And that is equal to 3 times x plus 3. So, what the heck, man? But you know what? Let's just do it. X plus 2, x minus 2, that's perfect square. Don't got to do any foiling with that. That's just going to be x squared minus 4. Now, x plus 3 times x plus 2, so x squared, these two terms together, which is going to be 5x, and 3 times 2. So this is going to be x squared plus 5x plus 6. The reason I'm putting it up here and not down here is because we're going to have to subtract by that whole thing. So let's distribute this invisible negative 1 into that. So we're going to get minus x squared minus 5x and then minus 6. All that equal to 3x plus 9. So x squared minus x squared, so we can just forget about those. Minus 4 minus 6, that is minus 10. And then we get minus 5x is equal to 3x plus 9. And now, more. Let's do some more. 5x. We want that x on one side. So I'm going to add the x's over here and then add just the 9 over here. Or subtract, really. So 3 plus 5, 8x is equal to minus 9 minus 10, minus 19. Divide by 8. Divide by 8. There's a very, I'm not yet used to writing diagonally, but this right here tells us that x is equal to negative 19 over 8. Voila.